Hello guys. So today we are going to look at the question design hit counter. The question says design a hit counter which counts the number of hits received in the past 5 minutes. Each function accepts a timestamp parameter in seconds granularity, and you may assume that calls are being made to the system in chronological order. You may assume that the earliest timestamp starts at 1 and it goes on from there. It is possible that several hits arrive roughly at the same time. So what this question is asking for is that you will be provided with a hit at a particular timestamp. You have to maintain a record of that hit, and when asked for the number of hits in the previous 5 minutes given a timestamp, you have to provide that number. Okay. Now there's a follow-up part to this as well. It says that what if the number of hits per second could be very large? Does your design scale? It means what if it gets exponentially large and it's hard. It might take up a lot of space on your memory to store those many number of hits coming to your system, So we'll address this follow-up as well in my solution. So let's first initialize the data structure. A good data structure for this problem, in my opinion, would be a dictionary or a hash map. If we are going to use a list, the drawback that I see there is, what if at the same timestamp you get multiple hits? How will you represent that? In a dictionary, you can just have the key as the timestamp and the value for that key as the number of hits that you received for that timestamp. So self.storage is a dictionary. Okay. Now the hit method is probably the easier one, where we just need to record the hit which came our way. Okay. So we'll just check if the timestamp is in the dictionary. If it is, then self.storage sub timestamp incremented by 1, right? The else part represents when you are receiving the very first hit for that timestamp. So you just initialize that key in the storage dictionary as 1. The value is 1, right? Now, the main part or the main method for this question, which will return the number of hits received in the past 5 minutes given a particular timestamp. And remember, the timestamp is chronological. So once you received a timestamp at 300, then you will receive a timestamp at 300 or after that, not before that. Okay, so we'll take advantage of that fact here. Okay, so let's first initialize the hits variable. Now, in this part, under this method, I'll take care of this scaling problem as well. What I'll do is I'll go through the storage dictionary, and for the keys which are within that 5-minute duration window, we'll keep those keys, and all the keys which are beyond that 5-minute window in the past, we just remove those so that we are scaling at the same time as well, right? So for key in list self.storage, if the timestamp that we received right now minus the key it's less than, this difference is less than 300, right? That means that key is within the 5-minute duration window in the past from that particular provided timestamp, right? Then we just update our hits as the value for that key, storage sub key. If the key is not within 300 units of difference, then we just can remove that, right? So self storage sub key. So we are scaling at the same time. And when we are done, we just return the hits that we computed. Okay, so let me just go through it once again. We initialize our data structure, which is a dictionary. Then we record the hit that we received at a particular timestamp in our storage dictionary, right? Now here we are computing the hits for the keys which are within the 300 unit difference from the provided timestamp for which we have to provide the hits. Else we just remove the keys which are not, and this helps us to scale as well. So let me run it. There's a success here. Let me submit it. There's a success there. So let me discuss the time complexity and space complexity for this solution. So time is, this is a constant time operation, constant time. Here is where the time complexity is computed. So we will be iterating over all the timestamps, all the keys representing the timestamps till the timestamp we are provided here. So we can say it's big O of n. The upper bound is n being the current timestamp that we are looking at, right? And all other things are constant time operation. So the time complexity is big O of n, as well as the space complexity as well, because the number of timestamp will be the number of keys that we have in our storage dictionary, right? So thank you guys.